Hello and welcome to the third part of my series about building a web API in Rust using Actix and Diesel. In this part we'll concentrate on the Actix part, which is the web API part. To do that, I'm building on the previous two parts where we integrated the database and Diesel. Now we'll go and build the handlers for the web API, and we'll do that simply by adding a handlers directory to the source directory. Here it is, handlers. Sorry, and we add a handlers.rs Rust file. Again, like with so many other things, we need to do the preliminaries. Which is basically this. We need to have Actix web. You see the different HTTP verbs: get, post, delete, put. We need the web, and we need to have the HTTP response, and we need to use the event and new events, repository, the database in the repository directory. So that's that. And we'll start by listing the events like we did with the database. It's not that difficult in Actix. The first thing we'll notice is that we have a get attribute here, because it's a get verb we use here. It's a list, therefore we can use get. It's more or less a convention. The function is asynchronous, because Actix is asynchronous, and we'll pass a DB of type web data of database, which is an injected value. We'll see later when this is injected. It's done in the main.rs file, but for now we have to assume that it's there and it's initialized correctly. It returns an HTTP response, easy, and then in the function itself, we request the events from the database, and then we return an OK. This more or less always goes right. The list can be empty, that's all. Let's, for simplicity's sake, assume that everything is always right. And the next thing, things might not always go right, because that is, like we did in the database, getting an event by a certain ID. Again, we have a get verb, and in the root, we see an ID, events / ID between curly braces. That's being used as a root parameter, as we can see in the path parameter of the function itself. This also returns an HTTP response. We'll find the event ID by calling the inner method on the path, which unwraps the ID. And then we get the get event, request a get event from the database, which we already defined in the previous part. Then two things can happen. Either we find it, in which case we return an OK with a JSON representation of the event, or we don't, and we get a none back. And then we return a not found, because that's basically what it is. We didn't find the event. But before we can do all of this, we need to be able to create events. So that's how we do this. This time it's a post, because it's not idempotent, so to say. Look at the REST specification. You'll see why I use post here. Again, async with a DB and with a JSON representation of the new event. That's how you do this, because we pass the new event data as a JSON in the body of the post request. Again, we request to create the event from the DB, and then two things can happen. Either everything goes smoothly and we return the event, or something goes wrong and we return an internal server error. Next, basically along the same lines, is the delete event. We pass the ID of the event in the root. We have the delete verb, as you can see. We delete it from the database, and two things can happen. It can go well and we return the event that was deleted, or something went wrong and we return an internal server error. The last of the web methods is the update method. This, like the create method, gets a JSON in the body of the event. This is a full event, not the basic, not the new event. We get the event is being deserialized into an event and passed onto the update event of the database struct. Two things can happen again. It can go well, or it can go totally wrong, and we have an internal server error. To make things a little easier for me and for everyone else, I also added the init routes function, which gets a service config. In it, we define the scope, which is the prefix we have in the URLs. This time it's API, and we define the different services: the get event, create event, delete event, and update event. That's it. Not that hard, I think. And then we need to add the mod.rs, like we did with every other directory. And we need to add the handlers and attach it to main.rs. That's it for the handlers. Now we need to go back to main.rs, where we already are. And we need to add some preliminaries here, because this is where the web server will start to run. Here we have Actix Web, again the app, the HTTP response, HTTP server, responder, everything. We have the logger, because we want to log everything that's happening, the serialize, and the Diesel migration, which we'll use in a later part, but I leave it on here. And we need to do this as well, I found out. Next, we define a response type, response struct, sorry. It can be serialized. Then we have a health probe, which will be needed if we are ever going to use this on Kubernetes, and a not found error, which is the default service. This just returns an HTTP response with a 404. Next, we have to add attribute Actix Web main. Main has to become asynchronous, and I have to spell it correctly, and return a result of none, or void in fact. Next, we instantiate, construct our database. Mice is red. Wait a minute. Called directory. And it shouldn't, because we should rename this. This was my fault. Refactor, rename, repository. Now everything's alright. Sorry, that was my fault. Things can go wrong. Then we define the app data. To be web data new. We add the events DB. This is the thing that is inserted into all the handler functions. And we'll see how that is done in a second. Next we'll define the logger. And now the great moment has arrived where we can define a web server. Let's go point by point. We build a new HTTP server with a new app. The app data is defined here, and that is the web data thing, web data object. We configure our routes using the configure method. We have added the health service, and we have the default service, it is the not found service. And then we add the logger. We bind it to an address, the 000, the local host address, at port 8080 on a local machine. We run and we wait. Let's see if everything compiles. I don't see that many errors. Let's see cargo. No problem. Then we can start running it. Now we have a problem. And that is the same problem that we had, that I found when I was first building this thing. The problem is that because of some multi-threading issues with the Postgres driver, Postgres DLL, things can go wrong, very, very wrong. And that is why we have to add a new DLL. How this is done and how you make this DLL? Well, making it, you have to rename something and then copy it into the target directory. I have one prepared beforehand. Let's see, project. this is called, Events Rust tutorial. We go into the target and we just copy this DLL. How this is done is all explained in the link in the description of this video. Let's see if it works now. So build works. I have to run it now. Because I'm on Windows, I get this dialog, not a problem. And then I can say localhost 8080 API event. You see it being logged. There's something about the fav icon, but there it is. Now it's time to start a postman, which I hadn't done. There we go. Also the same dialog. Here I prepared something. You can see I'm using the post, I'm using the localhost 8080 API events. It should probably be called event, but I'm using the raw body JSON. Let's see what happens. There we are. It works. And if we go to our local host now, we see it working. That's it. But there's still some things that need to be done. First of all, we need to be able to auto-migrate, so we don't have to do that by hand, or when we deploy to Kubernetes, for instance, or another deployment method. And we need to be able to deploy it, like to Kubernetes, as I mentioned. And those are the subject of the next videos. Thank you for watching. Don't forget to subscribe, and I'll see you in the next one.